In this video, we will define four terminal elements called control sources. The basic symbol of a control source is shown on screen. It consists of four terminals A, B, C, and D, and a pair of voltages V1 and V2, and a pair of currents I1 and I2. The four terminals are grouped into pairs of two each. For example, the terminals A and B are called the sensing terminals, and the terminals C and D are called the controlled terminals. Next, we will define four kinds of control sources. All of them will have the same basic representation as shown on screen, in the sense that they will have a pair of sensing terminals and a pair of controlled terminals. The first kind of control source that we will study is a voltage-controlled voltage source, abbreviated as VCVS. The sensing terminals for this source are A and B, and the controlled terminals are C and D. All controlled sources are drawn with a diamond symbol connected to the controlled terminals as shown on screen. The function of the sensing terminals is to sense the voltage V1 and not draw any current from the circuit such that I1 is equal to 0. At the controlled terminals, we have a voltage source shown by the diamond symbol, and the value of this voltage source V2 is equal to a constant A times the sensed voltage V1, such that V2 is equal to AV1 as shown on screen. The control terminals are connected to a voltage source, and the behavior of this voltage source is very similar to the source that we have seen previously, where if we were to plot the graph of the current I2 versus the voltage V2, then the characteristics of this voltage source would give us a horizontal line where the voltage would be defined as AV1 and the current I2 flowing through the source could have any value. To summarize, a voltage-controlled voltage source is defined by the characteristics where I1, the current at the sensing terminals, is 0, which is the same as an open circuit. The controlled voltage source V2 has a value of a constant A times the sensed voltage V1, and the current I2 can have any value and depends on what else is connected to the terminals C and D. The units of A, the constant defining the voltage-controlled voltage source, are dimensionless. The units of A are also sometimes given as volts per volt, which is also a dimensionless quantity. An example of the use of a voltage-controlled voltage source in a circuit is shown on the figure at the left on screen. We can identify the voltage source by the diamond symbol. The gain of this voltage source is 1/3, or the constant A is equal to 1/3, and the sensing voltage is V of X, which is circled. Since the sensing voltage V of X is the same as the voltage across the 90 ohm resistor, we can simplify the diagram a little bit and draw it as shown on the right hand side. The symbol for a voltage-controlled current source, or VCCS, is shown on screen. It consists of the sensing terminals A and B, where the voltage V1 is sensed and the current I1 is equal to 0, such that the sensing terminals behave like an open circuit. The controlled terminals are C and D, and we have a current source shown by the diamond symbol with an arrow inside it connected between them. The value of this controlled current source is I2, which is equal to a constant A multiplied by the sensed voltage V1. The voltage V2 across the controlled current source can have any value and depends on what else is connected to the source. The characteristics of this controlled current source are very similar to the independent current source, where if we were to plot the characteristics of I2 on the x-axis versus V2 on the y-axis, then it would be a vertical line where the value of the source would be equal to AV1 and the voltage V2 could have any value. To summarize, a voltage controlled current source is defined by the sensing current I1 is equal to 0 or the same as an open circuit. The controlled current source has a value I2 which is equal to A times the sensed voltage V1, and the voltage V2 can have any value which depends on what else is connected to the source. The units of A are the same as amperes per volt, which is the same units as conductance and is equal to Siemens. The symbol for a current controlled voltage source, or VCVS in short, is shown on screen. It consists of the sensing terminals A and B, where the current I1 is sensed, and since we have a short circuit between the terminals A and B, the voltage V1 is equal to 0. The controlled voltage source is connected between terminals C and D and is shown by the diamond symbol. The value of this voltage source is V2, which is equal to a constant A multiplied by the sensed current I1. The current I2 can have any value and depends on what else is connected to the voltage source. The characteristics of the current controlled voltage source can be shown by a graph, which consists of a horizontal line. The value of the source is given by A I1, and the current through it can have any value depending on what else is connected to the source. In summary, a current controlled voltage source can be defined as having V1 equal to 0 at the sensing terminals such that you have a short circuit. The voltage V2 is equal to A times I1, where I1 is the sensed current at the sensing terminals, and the current I2 can have any value. The units of A are equal to volts per ampere, which is the same as ohms. The use of a current-controlled voltage source is shown on the circuit on the left, where the controlled source is shown by the diamond symbol, and the sensing current is I of x, which is flowing somewhere else in the circuit. Since the current I of x is the same as the current through the 90 ohm resistor, the circuit on the left is simplified and shown on the right hand side, where I of x is shown as the current flowing through the 90 ohm resistor. The last and fourth kind of controlled source is a current-controlled current source, or CCCS in short. It consists of the sensing terminals A and B, where the current I1 is sensed and the voltage V1 is equal to 0. The controlled terminals C and D have a current source connected between them. The value of this current source is I2 and is equal to a constant A multiplied by I1, which is the current sensed at the sensing terminals. The voltage V2 can have any value and depends on what else is connected to the source. The characteristics of this source can be shown on a graph, which will give us a vertical line at the current value AI1, and the voltage V2 can have any value. In summary, this source can be defined by V1 is equal to 0 or a short circuit. The current I2 is equal to a constant A multiplied by the sensed current I1, and the voltage V2 can have any value. The units of A are amperes per ampere or dimensionless.